From UFOs to possible alien abductions, we're fascinated by the idea of extraterrestrial life. Now, scientists have found the strongest evidence yet that a planet 124 light years away could be home to life.
They thought it was just another rock, an ice-dusted fragment slingshotting in from nowhere. Cold, indifferent, meaningless, a coin toss from the outer dark. But 3I/ATLAS refused to behave. Its path kinked where gravity said it shouldn't. Its heat didn't bleed like a normal comet's, it pulsed. On, off, on, as if someone were flipping breakers in a building we couldn't see. And then the James Webb Space Telescope, that unblinking eye of gold and math, turned toward it. Webb didn't return poetry or rumor. It returned patterns, not random, not geological, patterns that looked like plans. Beneath the soot and frost, inside the spinning belly of an object older than any king or empire, something revealed itself. Long, narrow cavities stitched into a grid, right-angled intersections repeating at tidy intervals, thermal zones that lit up, then cooled, then lit again, like rooms in an apartment block waking floor by floor. The numbers didn't whisper, maybe. They said, look again. When the reconstructions were run, independent teams, different methods, the same contours reappeared. Corridors, nodes, chambers, a layout that resembled a city compressed into a traveling stone. City, the word jammed in every scientist's throat. Too bold, too loaded, too much, so they offered safer terms. Non-random internal morphology, geometric thermal anisotropy, modular void topology. But late at night, when the plots were still glowing on their screens, even the careful ones felt it. That sense you get walking through a silent building at 3 a.m., when you realize the power is still on. If this was erosion, it was the neatest erosion in the universe. If this was crystallization, it had a civil engineer's handwriting. If this was nothing, why did it keep looking like something? That is where our story begins. With a telescope built to peel heat from darkness, a visitor from another star, and a pattern inside it that should not exist. Not here, not now, not without a builder. Because the question is no longer, what is 3I/ATLAS? The question is, who designed a place inside of it? And why did they send it through our sky? Webb was never meant to chase rumors. It was built to take the oldest light in the universe and turn it into facts. So when 3I/ATLAS crossed the observing queue, the goal was modest. Get spectra, get temperatures compared to our comets, learn something new about a star system we'll never visit. The first passes delivered exactly that. A chemical cocktail that didn't match our usual recipes, and heat that pooled in patches instead of smearing evenly across the surface. Odd, but explainable. Rough terrain can make shadows. Fractures can vent like jets. Space is messy. Then came the map that wouldn't behave. Webb's instruments don't take pictures the way your phone does. They stitch wavelengths into information into shapes. When those shapes were rendered spatially, lines emerged where no lines should be. Not hairy, fractal veins like you'd expect in cracked ice, but tidy runs of warmth punctuated by cooler entrances, repeating at intervals that could be measured and, more unsettlingly, predicted. If you told a computer, find me the next hotspot, it could. The pattern wasn't only there, it had rules. Engineers did what engineers do, attack their own work. They checked calibrations, looked for crosstalk, and hunted ghosts in the pipeline. They flipped the algorithms, stripped out priors, and reran with different noise models. The scaffolding remained. It wasn't a single image artifact. It survived more than one method, more than one team, more than one night. So the question sharpened. Nature draws with curves and splinters. Cities draw with rulers. Which one, honestly, did this look like? To keep themselves honest, the teams pulled in comparables. Could a honeycomb of sublimation pits mimic hallways? Could layered anisotropic regolith cause right angles and heat? Could repeated venting along stress lines throw a false grid? For every natural mechanism, the simulations came back with the same verdict: plausible, but messy. Nature could hint at order, not spit out a floor plan. That's when the reconstruction group stepped in with a tool nobody wanted to trust, a multispectral, physics-informed AI that turns stacks of infrared data into 3D interior guesses. Think of it like an MRI for rocks. Dangerous if you're credulous, invaluable if you're careful. The first pass produced a honeycomb of cavities that looked almost municipal. Long run, cross corridor, central node, repeat. The second pass, done by a rival lab using different priors, retained the same skeleton with slightly different flesh. Some chambers hexagonal, others oblong, but the grid logic intact. Nobody printed alien city on paper. Nobody kicked down doors. But silence got heavier. The word people reached for wasn't artifact. It was layout. And the heat would not stop talking. These weren't just empty halls warming in sunlight. Some zones pulsed on cadences too clean for random venting. They cycled. They lagged and led each other as if connected by an unseen thermostat. When frequencies were swept, certain bands vanished into the structure as though something inside was designed to swallow them. Other bands bounced back hard like light off polished shielding. If you've ever walked past a power room behind a wall and felt the hum you can't hear, that's what the data felt like, a hum in math. The cautious take was simple and respectable. 3I/ATLAS is extraordinarily weird. The braver one was hard to say out loud. Someone built rooms in a rock and turned some of them on. Once you admit the possibility, not the certainty, just the possibility, that the interior is structured, the next test is proportion. Nature has favorite ratios. So do engineers. The reconstruction teams treated 3I/ATLAS like a crime scene and measured everything. Cavity length distributions, intersection angles, spacing between nodes, curvature of turns. What came back didn't read like glaciers and cracks. It reads like a handbook. A cluster of chambers favored hexagons. The same shape aerospace designers love for strength to mass. The same shape bees love for packing. Between them ran corridors whose distances fell into repeating bands, not exact clones, but modular, as if the designer allowed tolerances. Angles kept snapping to 90, 60, and 120 degrees. Natural fractures don't keep snapping to those. Blueprinted spaces do. Wilder still wore the verticals. In several volumes, the floors stacked at separations that would make sense if you were trying to conserve heat, move fluids, or traffic bodies that did not have our stride. Too close together for comfortable human movement. Too sharp at the corners for our knees. It was a place that might be navigated by something that flowed, slithered, hovered, or rolled. Anything but a biped with ankles and hips. That observation rewired the conversation. People had been asking, did someone build this? Now the question became, built for whom? The thermal nodes, those rhythmic repeating hotspots, lined up with choke points and hubs, places where you'd expect heat exchange or regulation to live if you were running an enclosed environment. Storage chambers, perhaps, stayed nearly cold. Transit corridors showed brief, traveling warmth, like a breath passing through a throat. The deeper cores stayed temperate and stubbornly opaque to certain frequencies, as if wrapped in a shielding we didn't have metaphors for yet. When the models were asked to simulate airflow through this lattice, the results were creepy in their elegance. Vents in outer cavities could inhale sublimated gases, move them through narrow chokes, and exhale through tailward ports. Not like a lung exactly, but like a building that breathes to stay alive. That idea wouldn't stick if the timings weren't there, but they were. On long integrations, the pulses in one wing lagged another by the same offset again and again, as if governed by a common clock. Skeptics, doing exactly what they should, hammered away. Maybe sunlight plus spin plus weird porosity can fake all of this. Maybe the reconstruction is pareidolia in 3D. Maybe the cadence is deep aliasing. Every criticism forced the models to get stricter, the assumptions to get thinner. With each pass, the randomness shrank but didn't vanish. Nothing proved a city. Everything kept refusing to look like chaos. And then a tiny, hateful number popped out of a routine most people had forgotten. A rotation frame residual, a subtle, repeating twist in the data that suggested mass inside 3I/ATLAS was shifting on a timetable, not tumbling, reallocating, as if tanks were filling and emptying, as if shutters were opening and closing, as if doors were moving. That's when the who questions turned from sci-fi speculation into engineering interviews with the future. If you wanted to survive between stars for millennia, you'd hide in rock. If you wanted to control temperature without wasting energy, you'd cluster your heat sources around junctions. If you wanted a system to wake near a star, you'd make it solar reactive. And if you wanted to be found only by minds that had learned to look in infrared, you'd make the signature visible only to a telescope like Webb. There is, of course, another possibility, colder and stranger. Perhaps this is not a habitat or a ship at all. Perhaps it is a recorder. A city-shaped machine whose corridors are waveguides, whose nodes are memories, whose pulses are not life support, but computation. Intelligence that does not sit in brains or wires, but in geometry and rhythm. If so, 3I/ATLAS is not carrying citizens. It is the citizen, a thinking place wearing a comet's coat. Either way, you can feel the trap snap shut on our comfortable ideas. If a city can live inside a stone, if thought can live in corridors and heat, then the universe we've imagined, empty, quiet, slow, is just the blank page where someone else already wrote. And as 3I/ATLAS skims through our neighborhood, turning its quiet, pulsing face toward our star, the most human question returns. Did it notice us noticing it? Because the pulses didn't change when backyard telescopes started. They changed when Webb started. When we built an eye good enough to see cities in the dark, the thing in the dark blinked back. The moment the thermal pulses were confirmed, the tone shifted in every control room watching. Ordinary comets don't breathe in rhythm. They sputter, vent, fracture, messy, chaotic. But 3I/ATLAS exhaled in measured beats, like a machine on standby. Infrared logs showed warmth clustering at nodes that looked suspiciously like hubs. One chamber brightened, then dimmed, then another warmed half a cycle later, as if the two were linked by a hidden switch. Over and over, the cadence repeated. At first, skeptics chalked it up to rotational quirks, but simulations failed to replicate the order. The pulses weren't just timed to the spin, they were timed to each other. Then came the strangest clue. Radio frequency sweeps vanished into certain cavities and never returned. Not scattered, not echoed, absorbed. It was as though the walls inside had been lined with something built to drink energy. Some bands bounced back sharp, others dissolved as if swallowed whole. Scientists know of no random mineral lattice that behaves this way across multiple frequencies. That's when one engineer whispered what nobody wanted on record. This isn't a comet, it's infrastructure. If the thermal cycles were the heartbeat, the geometry was the skeleton. The reconstructions built from Webb's multiband scans kept converging on the same eerie order. Corridors laid end to end, intersecting at clean right angles. Modules that repeated like apartment blocks. Central chambers with dimensions that scaled up looked like plazas or halls. Natural ice fractures don't repeat so neatly, yet here they were, regular as tiles. Some cavities were hexagonal, others fell into Fibonacci spacing, both shapes prized in engineering for efficiency and strength. The layout looked less like chaos and more like urban planning. And yet, the dimensions didn't fit us. Corridors were too narrow for human shoulders, turns too sharp for our stride. A being that slithered, hovered, or compressed could move through it easily. Not us, not anything we've built. When airflow was simulated, gases moved elegantly from chamber to chamber, venting outward in a pattern that looked engineered for regulation. It resembled a self-sustaining system, not a geological fluke. That was when scientists stopped asking, could nature fake this? And started asking, who was it built for? By now, 3 theories dominated every late-night call between observatories and defense agencies. The lifeboat theory, 3I/ATLAS, might be a fragment of a civilization's escape plan. Chambers for survival, thermal systems for regulation, shielding for the void. A city shrunk into a comet's shell, drifting until it found a star bright enough to wake it. The tomb theory. Perhaps no one survived. The structure could be a mausoleum, a memory pod, a frozen ark of people long dead. In this case, the pulses are nothing more than failing systems still ticking in the dark. A cosmic graveyard disguised as stone. The mind theory. The corridors and nodes might not house life at all. They might be the life. A geometry that computes, a pattern that thinks, an intelligence woven into architecture itself. In that scenario, 3I/ATLAS is neither a vehicle nor a relic. It is a being, not dead, not alive, but aware. And if that's true, then Webb hasn't just found a city, it has locked eyes with something that looks back. The final piece came not from heat maps or AI reconstructions, but from motion. Webb's ultra-sensitive sensors, designed to track infinitesimal shifts in galaxies billions of years away, caught something small, yet undeniable. One of the internal chambers inside 3I/ATLAS moved, not by much, just a tilt of 0.02 degrees, but enough to register. The timing was worse than coincidence. A powerful solar flare had just swept through the region, dousing the interstellar traveler in electromagnetic radiation. And then, as if stirred by that surge, the chamber flexed. Skeptics called it thermal expansion. Engineers compared it to a frozen pipe cracking, but others weren't so sure. The alignment of the movement matched one of the thermal pulse zones. To them, it looked less like an accident and more like a system booting. A door, a valve, a mechanism answering the star. That possibility turned the object from curiosity to threat, because if 3I/ATLAS reacts to sunlight, then its passage through our system may not be idle. It could be deliberate, a hibernating probe designed to stir only when it finds a living star. If that's the case, then our sun just woke it up. Military satellites pivoted overnight. Communication dishes recalibrated. For the first time, governments whispered openly about contact protocols drafted decades ago but never used. Because if this thing is active, then by pointing Webb at it, by watching so closely, we may have already answered a call we never knew we were making. So here we stand, on the knife edge of possibility. A telescope built to glimpse the birth of galaxies may have just stumbled on a secret buried inside a stone from another star, a grid of corridors, pulses of heat, a chamber that twitched when kissed by our sun. Is it a lifeboat, a tomb, a machine that thinks in silence? We don't know. Maybe we can't know. But one truth cuts through the noise. Whatever 3I/ATLAS is, it isn't ordinary. It isn't just a rock. It carries intention, geometry too precise, rhythms too steady, alignments too deliberate. And that means, for the first time, humanity may be staring at the work of another mind. Not a signal, not a landing, just a silent city riding inside a comet, drifting close enough for us to glimpse it, then vanishing back into the dark. If that was the plan, it worked. Because now we can't unsee it. Now we have to live with the question, did we discover 3I/ATLAS? Or did 3I/ATLAS decide to reveal itself? And if it noticed us the moment we noticed it, then history will remember this not as the day we looked into space, but the day space finally looked back.